This is one of the pivotal places in the world. This is unlike anywhere else.
I think anyone who comes and views the wonder of the falls has very strong feelings, perhaps even spiritual feelings.
You've got this beautiful, magnificent natural feature, a waterfall that drops 270 feet.
Anywhere you stand, you can feel the ground vibrate.
You actually see the power that it has. It's not just a matter of the natural beauty. It pulls people to it.
The allure and power of Snoqualmie Falls captivated one man in particular who envisioned harnessing the energy of the falling water to bring electricity to the greater Seattle and Tacoma region. Utilizing technology still in its infancy, the power plant carved out beneath the cataract was an engineering marvel of the 19th century. The impact of electricity in the Puget Sound region grew exponentially to a point where, today, it is difficult to imagine life without it. More than 100 years later, the plant continues to generate electricity, with original equipment still powering the Pacific Northwest. For as long as we can trace back our human ancestry, people have been lured to the power of Snoqualmie Falls for both spirit and sustenance. According to Snoqualmie tribal tradition, the falls was created as a place to gather resources for the tribe.
The origin story that I have for the Snoqualmie Falls is something that was shared by a Snoqualmie tribal elder whose name was Siatuchtud. In this story, we meet a being by the name of SNOQUALMIE, who is Moon the Transformer. The work of Moon is to be the person who is going to go around and change plant and animal species, change the landforms, make the world so it's going to be ready for the human beings who don't exist yet. As he's coming upstream, he comes to the place where Snoqualmie Falls is now. And there was a fish trap that was stopping the fish from going further up the river. And so Moon thinks this is not a good thing. He started the salmon coming up so that the people have something to eat. So he changes the fish weir into Snoqualmie Falls. So you can imagine the fish weir transforming into this majestic falls that we see now. And he tells Snoqualmie Falls what its job is going to be. You, waterfall, shall be a lofty cataract. Birds flying over you will fall, and people shall gather them up and eat them. Deer coming down the stream will perish, and the people shall have them for food. Game of every kind shall be found by the people for their subsistence.
For generations, the Snoqualmies gathered every summer at the banks of the falls, taking pride in its beauty. The first American to write about the cataract, Samuel Hancock, was led to the falls by a Snoqualmie guide. Hancock called it a most beautiful and imposing spectacle. 3 years later, 2 U.S. Army officers were sent to measure its height. Using a thread, they calculated the falls to be 260 feet high. Word of the falls soon spread, encouraging adventurous travelers to make the trek to the site. The growing attraction prompted the construction of a hotel on the south side, allowing visitors the chance to stay overnight and savor the natural beauty. The allure of the falls transcended culture, and it wouldn't be long until the myth of its power would be transformed into reality. Snoqualmie Falls is situated in a small valley on the western border of the Cascade Mountains. The waterfront town of Seattle lay some 30 miles to the west. In the 1880s, Seattle counted 3,500 residents and was only the second most populated city in the Washington Territory, behind Walla Walla. But all that would change in a matter of years. As the United States entered its Gilded Age, the Northern Pacific spanned the continent, connecting to Seattle in 1884. Migrants flooded west, and the promise of a new innovation called electricity began to emerge. Powered by coal and steam, small power plants sprouted up throughout Seattle, with a singular purpose of providing electricity to major industries. Earlier, in 1879, a man known as the Wizard of Menlo Park had introduced a device that would usher in this modern age. Thomas Edison's incandescent light bulb proved to be such a sensation, he built his first factory to mass produce his invention in 1882. That same year, a lumber mill in Tacoma used electric lights to operate throughout the day, and now into the night. While industries utilized this new source of power, the residents of Seattle and the Northwest still squinted through the night using candles or oil-burning lamps. Coal, kerosene, and even foul-smelling dogfish oil were the primary fuels of the day. Street lights were illuminated with coal gas, pumped through wood piping buried in the streets. All the options generated heat, smoke, and noxious odors, not to mention the risk of fire.
Most of America burned down at some point in the late 1800s. And that was because of the reliance of actual fire for doing work.
The solution to these frequent fires was brought to the Northwest by Edison representatives who fanned out across the United States like missionaries, bringing the message of electric lights. On March 22, 1886, Sidney Mitchell arranged an exhibition at Jackson Street near Commercial.
11 16-candle power lamps were stationed along the room, and when sufficient steam was accumulated, the dynamo was started, the lights turned on, and the room was immediately made brilliant with a clear white light. The company has orders for 400 lamps now, and it is expected that the demand will greatly increase as soon as the advantages of the light become apparent to the people. Seattle Post-Intelligencer.
Not everyone rejoiced at the innovation. Gas company employee Charles Powers sabotaged the electric generating dynamo, delaying this new form of illumination for months. Despite the setbacks, Edison formed the Seattle Electric Company with local businessmen and obtained a franchise from the city council to run wires along streets and alleyways. In these early days of electricity, it was clear not everyone had a firm grasp of its principles. In one editorial, a Seattle resident wrote,
"How foolish of these young men to build the generating station on the waterfront. If they had put it at the top of the hill, the electricity would run down the wires by gravity. Now they'll have to pump it."
The public's ignorance of this new technology was matched by its suspicions of its danger. Seattle's first electric streetcars, launched in March of 1889, worried many that the current would magnetize watches and lightning bolts would kill passengers and pedestrians. But 3 months later, in the summer heat of June 1889, public sentiment would change. A spilled glue pot ignited a fire in downtown Seattle. Fueled by kerosene lamps and bursting gas lines, the blaze skipped from building to building, destroying 64 acres of the waterfront city. Confidence in the relative safety of electricity grew, especially when locals witnessed streetcars emerging from the smoke and chaos with little more than blistered paint. By the end of the decade, more than 100 miles of streetcar lines traversed the city, making Seattle one of the most electrified cities in the nation. By this time, Edison had built 121 direct current power stations across the country. Edison's ability to promote this new technology was undeniable, but the problem with direct current was that it could not be transmitted further than a mile, requiring every neighborhood to have its own coal-burning steam power plant. In the midst of this age of electricity, a 23-year-old Cornell University graduate stepped off a Mosquito steamer in Seattle in 1887. His name was Charles Hinckley Baker, and with a degree in civil engineering, he found work with the Seattle, Lakeshore, and Eastern Railroad.
I think that Charles Hinckley Baker was a young man who wanted to make his mark in the world and thought of that as being a good thing.
Early in the young engineer's career, he was assigned to plat an area of the Cascades that would lead him to a site that would spark his imagination.
The line passed within 50 feet of the Great Snoqualmie Falls Cataract, which at that time had no commercial value, and it was only thought of as a place of resort for fishermen, tourists, and campers. In the performance of my particular duties, there was hardly a week passed that I did not see this wasting waterfall, and it came into my mind at that early time that someday its power would be carried to the distant cities for utilization there. Charles Hinckley Baker.
I think Charles Baker was looking for the excitement of discovery and creation.
When Charles Baker saw this site, he saw an opportunity.
Baker fully understood the expense of excavating and transporting coal to fuel steam plants that powered the industries at the time, and saw the falls with its never-ending supply of water as a means to deliver power for a fraction of the cost. With dreams of his own, Baker left the railroad and started his own company to capitalize on the new technology of electricity. One of his first clients was Seattle pioneer David Denny, who hired Baker to build a streetcar line from downtown to the University District. With the assurances of Denny, one of Seattle's wealthiest businessmen, Baker extended his own line of credit, purchasing supplies, materials, and equipment to start the line's construction. But the panic of 1893 triggered a massive economic blow, wiping out Denny's entire fortune. Baker was left holding notes for $100,000 worth of unpaid bills. A 5-year depression left millions of men across the nation without jobs. Railroads went bankrupt, and investment capital evaporated. Under the pall of the 1893 Depression, the Chicago Columbian Exposition offered the optimism of the future. Charles's father, William Taylor Baker, was head of the Chicago Board of Trade and president of the 1893 Exposition. A friend of William Baker was invited to the exposition to demonstrate the capabilities of alternating current, a competing technology to Edison's direct current. At twilight on opening day, George Westinghouse threw the switch, illuminating 250,000 handmade electric light bulbs. Crowds stood in wonderment as building interiors and the grounds around the site glowed with electric light. The demonstration had once and for all With his father's financial support in place, Charles Baker began the bewildering task of envisioning the multitude of elements necessary to turn falling water into power.
There were a tremendous number of unknowns. I mean, they didn't really know the geology of the site. They didn't really know how this technology was going to work. It can't be emphasized enough. This was pretty cutting-edge technology.
He had to think about how to put all the pieces together, how to hollow out a cavity that's solid rock, big enough to put generators, turbines. He didn't have a hardware store down the street he could go rely on. He had to get enough crew that were knowledgeable enough to put all this together.
Building the powerhouse at the base of the falls would expose the sensitive machinery to the perpetual mist, causing corrosion over time. Instead, Baker decided to construct the plant underground behind the falls, similar to the one built at Niagara. But unlike Niagara, where the turbines were under the falls and the generators were on top, Snoqualmie's powerhouse would be completely underground, an engineering feat that had never been attempted. The idea proved even more daunting, considering he would need to dig 250 feet down through solid rock. The project's massive scale and remote site required skilled engineers, dozens of motivated laborers, as well as the infrastructure to support it all. With Seattle still recovering from the financial hardships from the Panic of 1893, men were hungry for work. As soon as Baker announced his plans in local papers, 3 men from nearby Falls City hiked to the top of the falls looking for jobs. Baker hired them on the spot and named one as the construction superintendent. Shortly thereafter, Baker had amassed a crew of 35 men. As the winter snowpack on the Cascades began to melt in March of 1898, the groundwork on Baker's hydroelectric dream began.
Charles was fortunate in that he didn't even have to build a serious railroad spur. We had the Seattle Lakeshore and Eastern Railroad coming right by the lip of the falls.
None of the major equipment was made in this part of the world. All of that had to be brought across country by rail and brought to the site by rail.
Baker's men laid down track, connecting the Seattle Lakeshore and Eastern Railroad to the construction site, and erected a 5-story hoisting tower that would lift the immense cargo from the arriving train cars. With the means now in place to receive supplies, equipment, and even crew, houses were then built on site for Baker and his superintendent, while a dormitory was constructed for the crew. The town of Snoqualmie was a mile away, and although employees and their families could shop and go to school there, the men needed to be on hand at all times. Married men and their families lived in 4 cottages, the largest for the superintendent. Single men bunked in a 10-room dormitory where they took their meals. A guest house, also called the President's House, sat highest of all the structures, with its sweeping view of the power plant buildings and the top of the falls. The cottages rented anywhere from $7 to $12 a month. While lodging was constructed, supplies were ordered. Baker shipped in 20 tons of dynamite, an air compressor system, hard rock drills, and 2 massive steam engines to power the operation.
They had to build their own steam plant on the original riverbank in order to run their hydraulic drills, in order to run the hoist that would be used to pull the rock out of the cavity.
Baker then hired the Puget Sound Bridge Company to build a 15-foot cofferdam to keep the river at bay from where they would begin blasting away into the bedrock. Finally, on April 18, 1898, the drilling began. Using steam-powered drills, 10 at a time, the crew bored down into the volcanic basalt. Mining laborers, known as powder monkeys, tamped the dynamite into the holes and touched off the charges. For weeks on end, day and night, the echoes of the dynamite blasts could be heard for miles as the crew slowly carved out a shaft that measured 10 by 28 feet.
This was not a mining operation where you could get in and go away and you didn't have to think about the site anymore. This is a place that still had to be watertight and stable for the long-term future after it was done.
After the smoke and dust cleared from each blast, workers hoisted out the rock. The large boulders were then crushed and deposited along the riverbank to be used as the base for the transformer house and support shops. On and on the blasting and clearing continued. When the shaft reached a depth of 250 feet, laborers pointed their drills northwest and began to carve what Baker called the Great Subterranean Chamber that would house the water wheels, generators, and control system.
They hollow out the cavity to give enough room to situate the generating equipment.
The cavity is 200 feet long. That's the length of 2 basketball courts placed end to end, 40 feet wide, 25 feet tall.
That is pretty incredible. It's not sand, it's not dirt. This is solid rock.
As the cavity neared completion, part of the crew set out to drill another 400-foot tunnel for the tail race, the channel that would return water to the river. A 700-step stairway was built down to the base of the falls, where another crew of men drilled from the opposite side.
This was carefully surveyed out. They began drilling in 2 directions at once, with a great deal of confidence that they were going to meet in the middle.
The plan worked, and within weeks, the downstream crew punched through from the far side.
After they were finished pulling all of the rock, all of the spoil that they were pulling out of the cavity, the equipment pieces, the turbines, the generators, and everything, all of that had to go down the elevator shaft.
The largest piece weighed 26,000 pounds.
This is heavy stuff, even with modern machinery. But in that day and age, without modern machinery, incredible feat.
Along with the generators, water wheels, and control equipment, Baker's men lowered in sections of the penstock, a steel pipe 7.5 feet in diameter that would carry part of the Snoqualmie River deep into the cavity. Riveters hammered together each 8-foot section, caulked the joints, and attached the penstock to steel receivers which fed the water wheels. An elevator, powered by its own penstock and water wheel, allowed men and equipment to move up and down the shaft.
All the foundry work, they had to create the molds. There wasn't any to really go by. They had to create just about everything.
Because of the isolation of this particular facility, there was a need for the staff that worked here to be ingenious in creating the pieces that they needed.
You actually had people who could do anything. Electrical, welding, mechanical, didn't matter.
The guy that's pulling a rock out with his bare hands, to the foreman that's putting the crew together day in, day out, there was no letting down. They all wanted to see these units run. They bought into it in a big way.
To see the progress for himself, Charles's father, William, traveled from Chicago to the site on 3 occasions. Impressed with the plans and the speed of construction, William felt secure in his investment, which today would amount to $15 million.
Father's absolute and unwavering faith in my integrity, judgment, and skill in these matters were the principal security for his money advanced in connection with our work. His belief in me was never shaken. Charles Baker.
While work continued at the plant site, detractors mounted a public relations attack slandering the engineers' efforts, claiming that Snoqualmie Falls ran dry in the summer and froze solid in the winter. So-called experts pointed out that water power had never successfully driven an electric lighting system and called the whole venture Baker's folly. While Baker dodged and confronted these political affronts, he also battled the forces of nature and the challenges of working with a technology still in its infancy.
One of the trials and tribulations he went through when everything froze up and there are these big long icicles hanging down and everything is totally draped in ice. So my grandfather had a lot of things to overcome.
When Baker purchased 2 water wheels, they were so new that the manufacturers refused to warranty them, with good reason. After having these enormous units shipped to the Northwest, loaded down the elevator shaft and installed, when run at full speed, the wheels vibrated so violently that they threatened to destroy the steel penstock.
But that was so inefficient. I think they only got something like 20% of what they expected to get out of the generators. It made so much noise, I understand that you could hear it clear down in Falls City.
The stress Baker shouldered was almost too much to bear. His health deteriorated, and in the midst of building the plant, he required an emergency surgery to remove his appendix, a procedure that had only been performed for little more than a decade. While Baker recovered, construction continued. 2 new water wheels were ordered from the Abner-Doble Company to replace the faulty units. While those were installed below, above the cavity, the transformer house began to take shape. The building contained electric transformers that would step up the voltage before sending the power across the transmission lines.
The harnessing of a river for the manufacture of electrical energy is a mammoth undertaking. Halted in its mad rush to the sea, the water is diverged into the turbines of the powerhouse. The generated power is sent out over miles of transmission lines, while the pent-up water, released again, runs merrily on its way to the valleys below, there to perform other duties for mankind.
Baker's plans did not end with a power station buried in a mountain. While crews assembled the generating plant, Baker himself set out to find a path to send the electricity from Snoqualmie to Seattle and Tacoma.
The transmission lines had to be built to Seattle and to Tacoma through forests that had 250-foot high trees, so they really had to do some serious logging.
Logging crews cleared a path some 300 feet wide that traversed forests and hills from Snoqualmie to Issaquah to Renton and then to Seattle. While the material to build the 2 sets of electrical poles was readily available, the aluminum transmission lines, insulators, and all other supplies were brought in by horses.
Probably no mountain lines have cost more for right-of-way than those from this plant. For not only do they surmount extremely difficult mountains, but they lead through continuous forests of dense spruce and fir, the trees of which are of great size. The New York Times.
They had to construct not only the transmission wires, but also the substations along the way. Substation in Issaquah, substation in Renton, to be able to get the electricity into the customers. Now that's over tens of miles. And if you look at pictures, there's a road following the transmission line all the way down, and people would go on horseback up and down that to check on the integrity of the wires.
By midsummer of 1899, crews that had been working around the clock in 3 different shifts completed the final adjustments and the last system checks. The only question looming in the minds of everyone was, would it work? When Charles Baker reflected on the months that had just passed, he was not modest about the gamble he made and the toll it took.
No man sacrifices absolutely all other prospects, mortgages his brains to one thing, gives up all thoughts of any other future, impairs his health, strength, and vitality, and suffers the nightmares and man-killing nerve strain, such as I have done, for any salaried compensation in money whatsoever. Charles Baker.
On July 31st, 1899, Baker gathered his wife, his daughter, his chief engineers, and a host of dignitaries at the temporary powerhouse at South 3rd Avenue and Main Street. At 8 o'clock, operators directed the waters of the Snoqualmie River into the penstocks. Falling 250 feet, the water shot through jets aimed at the Doble water wheels that spun the generators and induced a current. In the transformer house, operators closed the circuits, sending power over 38 miles of transmission lines to Seattle. Baker held his daughter Dorothy in his arms.
The child, with the look of wonder on her face, pressed the handle gently and smiled as a blue spark ran among the machinery. The lights burst forth brilliantly, and the words "Snoqualmie Light" appeared on the powerhouse just below. A flash of light, a whirring of machinery, and the expression of triumph in the faces of those who had the courage to embark on one of the greatest undertakings in the West. The great force of Snoqualmie Falls had been harnessed and was now subject to man's manipulation. Seattle Post-Intelligencer.
One can imagine the grin on Charles' face when this really began to work, and he could see that all of his energy and time and his father's resources were going to come to fruition.
Had to be a real inspirational moment. He went through the long, hard process of putting this place together, and the camaraderie that was developed between himself, all of his engineers and the crew.
From unbroken rock to pull the switch that lit up the lights on the side of the Snoqualmie Power Company in downtown Seattle in 16 months.
It's just amazing. And this had never been done before. This was the first power plant constructed underground.
He wanted this to be something that not only everyone would see as his accomplishment, but they would see as their accomplishment as Americans. You know, this is the sort of miracles we're working nowadays, folks. And it's not only useful, it's beautiful.
Civic leaders, businessmen, and locals were duly impressed, some calling it the eighth wonder of the world. Baker had done it. It was an unparalleled engineering marvel of its day, financed entirely with family money and completed in an improbable time frame of just 16 months. This made all the more impressive by the fact that no deaths occurred, nor even a major injury during its construction. Baker had every reason to be proud of his accomplishment, but wouldn't rest for long. The new technology had generated enough skepticism among Seattle residents that Baker had launched his own public relations efforts. Over the course of the plant's construction, he wrote numerous articles for magazines, newspapers, and scientific journals, and guided dozens of civic leaders on tours of the plant.
His vision was to put the power plant here and to show it off to the world. The grounds were manicured, the buildings were beautiful.
I think some of the architectural features that fascinated us include the attention to detail that you wouldn't ordinarily expect to see in an industrial site. The brick corbelling, arched windows of the classical revival style.
Charles Baker's plan was that the appearance of the grounds and the buildings would be part of what would draw people.
He wanted it to be the sort of place that people could come and see what the marvels of the new electric age were going to look like.
And was always willing to talk to anyone who came to visit the power plant.
This is the 1890s. The average person didn't realize what an effect this was going to have on their lives in a very short time.
While the architecture of the buildings created a beautiful setting, more importantly, they housed the essential elements needed to keep the plant operational.
The machine shop was built primarily as a support structure for the project to machine pieces that the plant would need.
I think a lot of that was because he wanted to make sure everything was right and was done well.
Besides Baker's adherence to quality, the machine shop produced parts that would have taken weeks to replace.
When things broke, they couldn't go somewhere to get a spare part. They had to have the facilities here to make whatever they needed.
Deep in the cavity, Baker's men began installing the third and fourth generator. Crews, meanwhile, continued to clear a 26-mile path through the forests between Renton and Tacoma and hung transmission lines to the city on Commencement Bay. With an eye to the future, Baker knew that he could gain more customers by extending the distance of electricity's reach. Compelled to push the technology even further, in November of 1900, Baker staged an unprecedented experiment. He redirected the circuits so that electricity ran from a generator in Snoqualmie to Seattle, back to Snoqualmie, then to Tacoma, and then back to a generator at Snoqualmie. Though the two units were only 10 feet apart, the current would have to travel a total distance of 154 miles. When Baker closed the final circuit, the 1,500 kilowatt generator began sending power to the other generator, effectively turning it into an electric motor. News of Baker's results traveled across the AP wire, where it was picked up by the American Institute of Electrical Engineers in New York and confirmed as the longest transmission of electrical energy in the world.
The transmission was an absolute scientific milestone for AC electronics.
The experiment had proved Baker's gamble on alternating current was a sound bet and opened the door for more widespread use of hydroelectricity.
During the past 20 years in the history of electrical engineering, there has not been a time during which the work on the Pacific coast has not attracted the attention of scientific men. But the marvels of recent accomplishment are almost beyond the comprehension of the lay mind. The New York Times.
By March 1901, Baker finished phase 1 of the first completely underground hydroelectric plant in the world. The power generated at Snoqualmie Falls was produced with such efficiency that it cost 1/3 to 1/2 of that from steam-powered plants. Baker was poised to enter the electric market, but soon found that delivering power and selling it to consumers were two different matters. During the construction of the Snoqualmie Falls electric plant, the Boston firm of Stone and Webster quietly worked behind the scenes, consolidating several of Seattle's independent power systems and streetcar lines into the already established Seattle Electric Company. Representing this Stone and Webster subsidiary was Baker's chief nemesis, Sidney Mitchell, the man who first brought electric lights to the Northwest. Mitchell held fast to the company line that no water power had ever been mechanically or commercially successful, and that no water power ever would be. Under generous franchises granted by the Seattle City Council, the Seattle Electric Company had amassed a monopoly and charged whatever rates the market would bear with little government regulation, much to the annoyance of Seattle residents. When Baker applied to the City Council for a franchise of his own, he found that he was expected to pay the city for the privilege and could never charge any customer more than his lowest rate. The inequity Baker faced did not go unnoticed.
As for Mr. Baker and his company, there are not enough strong expressive adjectives in the English dictionary to tell of the injustice that they have received at the hands of those in collusion with the Seattle Electric Company. The Seattle Mail and Herald.
In an attempt to sidestep the franchise restrictions, Baker created separate entities, the Seattle Cataract Company and the Tacoma Cataract Company, that would own and operate the transmission lines to those cities. But Mitchell and his allies were still able to freeze Baker out of the Seattle market and even offered to buy him out. Challenged to operate under such lopsided restrictions, Snoqualmie Power Company was only able to sell electricity directly to a hotel and 2 flour mills. The rest he was forced to sell wholesale to the Seattle Electric Company. In Tacoma, Baker found the political atmosphere to be slightly more receptive, as the rates Stone and Webster's affiliate charged were considered excessive. Even so, Baker was still characterized as an outsider. The Tacoma Ledger labeled him a member of the Chicago Ring and portrayed him as having hypnotic control over Tacoma's mayor and city council. More adept now at these political games, Baker planted false information about his rate proposal to the Tacoma City Council with a banker he knew to be one of Mitchell's informants. Mitchell took the bait and confidently submitted his bid. Baker underbid him by a penny per kilowatt hour and clinched the deal. By outmaneuvering Mitchell, Snoqualmie Falls Power managed to clear close to $100,000 by 1902, more than $2 million of profit in today's value. But Charles and his father William were less concerned with short-term profits. Baker drew only a small salary for himself, directing all the surplus revenue into his newest venture, a power plant on the White River in Pierce County. It was a project he took great pride in, claiming that it would be the largest single power development in the world. The father and son handshake partnership combined shrewd financing, engineering ingenuity, and a vision that this infant technology would mature and grow, providing power to every home at a reasonable rate. Their partnership presented an unstoppable force that would endure for decades. But all that would change in a matter of weeks. On the night of September 16, 1903, an operator in the cavity smelled smoke. He rode the elevator up to the transformer house just as flames engulfed the structure. Burning transformer oil flowed down the elevator shaft and into the cavity.
35,000 gallons of oil caught fire. The newspaper accounts at the time talked about there being burning oil miles downstream from the plant.
By the time the fire was extinguished, 10 of the 13 transformers, the elevator, and 3 generators were nothing more than charred wrecks. That same night, other fires destroyed a private power company in Seattle and the battery room of the Seattle Electric Company. Baker suspected foul play, but all the events appeared to be accidents.
Charles Baker was always, for the rest of his life, was suspicious that they had been set by his competitors. And of course, Snoqualmie Falls was open to the public during the entire time that he controlled it. So there is always that possibility that someone was here.
Had the fire occurred a week later, much of the damage could have been averted as Baker's men were preparing to move the transformers into fireproof compartments. The Snoqualmie Falls Power Company had been severely crippled and could provide only a fraction of its normal power. The Seattle-Tacoma interurban, powered entirely by the falls, immediately switched to electricity from nearby steam plants and never lost service. Businesses and city streets in Tacoma and Renton, however, went dark, leaving residents searching for candles and kerosene lamps. Baker's men, who had taken great pride in the plant's construction and operation, took it personally when the plant was nearly shut down and worked at a feverish pace to repair the damage. Miraculously, just 36 hours later, the plant came back online with 1 generator, 3 salvaged transformers, and a privately contracted steam plant. As Baker and his men were catching their breath, on October 6, 1903, just 3 weeks after the fire, Charles's father, William Taylor Baker, died suddenly in his sleep. Charles was stunned by the unexpected loss and later wrote of his father,
"No father, by his constant attitude, ever paid a finer tribute to a son than this father thus did to me, and no son ever felt a keener regard for a father's welfare and happiness than I did for mine."
His father had been a significant backer and believer in his son. This had to have been a very traumatic issue for Charles.
In the midst of his grief, Baker was sent into a tailspin when he realized that his father, who was the majority shareholder, had left no will and no written agreement between them.
The tragedy is that Charles and his father had done handshake rather than written agreements. And some of these did not hold up in court back east.
Charles Baker explained to the estate administrators that he was a 50-50 partner with his father in Snoqualmie and White River, but he was unable to produce any written agreement. The administrators, now controlling the board of directors, acknowledged Charles's tremendous contributions as president and chief engineer, but would not recognize the oral agreement. Baker suspected the hand of Sidney Mitchell and his Confederates behind the scene pulling strings. Within a year, during which Baker rebuilt the plant, his father's estate administrators liquidated and sold all of the assets. By 1904, the creator, builder, and financer of Snoqualmie Power was forced out. Many of his best employees followed him in disgust. Charles Baker was left to begin anew, steadily rebuilding his fortune in the southeastern part of the United States.
My grandfather went on to Florida, and my mother and grandmother saw him on a newsreel pounding the golden spike with the governor on a Florida railroad that went north and south.
He simply moved a long way away and became incredibly successful as an engineer.
Though Baker was often maligned and discredited by the Falls' new owners, in 1905 they continued with his plans and added a fifth generator in the cavity. In the intervening 5 years, electrical technology progressed by leaps and bounds. Instead of installing another water wheel, they purchased the latest Francis turbine. With far greater efficiency, the new turbine in Unit 5 could generate 5,600 kilowatts, almost as much as the first 4 units combined. The additional power allowed the company to offer electricity to customers in Everett, 44 miles away. Baker's successors decided to scrap the plans for the White River project, leaving its completion to Sidney Mitchell's Pacific Coast Power Company. By 1910, demand for electricity, however, continued to grow, prompting the Seattle Tacoma Power Company to consider a second plant at Snoqualmie Falls.
What prompted the building of Plant 2 was the success of Plant 1. They could see that this was going to be a very successful endeavor.
It was always Baker's plan to expand the cavity in the opposite direction. But drilling and blasting threatened the operations of the Snoqualmie plant, on which so much of the Puget Sound region had come to rely. Managers opted for a second independent plant, whose powerhouse would be built well below the falls, beyond the mists that threatened the delicate electrical machinery. Though Plant 2 would not be built underground, it presented its own logistical challenges. The railroad that hauled in machinery, equipment, concrete, and sections of the penstock would need to be supplemented. On the Plant 1 side, narrow gauge tracks were laid down to the riverbank, where a ferry built on site would transport supplies across the river, up the other side, then down the face of the cliff in a series of switchbacks.
Plant 2 is another marvelous engineering feat. The big challenge was, in order to protect the scenery here, they had to bore a tunnel underneath the area where the old Snoqualmie Falls Lodge was.
The sounds of drills and blasting returned to Snoqualmie Falls as crews bored again through the solid rock on the north side of the river. This time excavating a tunnel 14 feet wide and 1,035 feet long. Blasting often sent rocks across the river and through the windows of Plant 1's transformer house. At the end of the tunnel, a 250 by 20-foot forebay was hewn out of rock to create a reservoir. From the forebay, water entered the gatehouse where headgates controlled the flow into the penstock. The riveted steel penstock dropped down the face of the cliff to produce a head of 255 feet, almost as strong as Plant 1. The structure built to house the generator was designed for industrial purposes only, with little regard for its architectural style. The newest Francis turbine was installed with room for 2 more units. This generator churned out 13,000 kilowatts, more than all 5 units of Plant 1. On December 1st, 1910, Plant 2 went online, doubling the output from Snoqualmie Falls. Current from Plant 2 helped power electric locomotives, on the western end of the Chicago, Milwaukee, St. Paul and Pacific Railway as they came across Snoqualmie Pass from Ellensburg. Another big power customer moved into the area in 1914 when the Weyerhaeuser Company opened its mill just upstream and built the company town of Snoqualmie Falls. Earlier in 1912, the Seattle-Tacoma Power Company had accepted an offer of $150 a share from Stone & Webster to become part of Puget Sound Traction, Light and Power. The Boston firm now embraced all the electrical utilities of Puget Sound, from Bellingham to Olympia, and most of the street and interurban railways. The increasing capacity and spread of electricity fueled economic growth throughout the Puget Sound region and the country. Industrial use of electricity allowed plants to utilize labor-saving devices, increasing output and lowering prices. Electric interurbans ran from Tacoma to Bellingham, spurring the growth of suburbs and allowing farmers to sell their produce at city markets. In 1905, Seattle City Light supplied electricity to its first residential customer. 4 years later, President Taft sat in the White House and pressed a telegraph key that illuminated the Alaska-Yukon Pacific Exposition on the University of Washington campus. Over the next 2 decades, electricity evolved from a mysterious force of nature into the most common household convenience. Electric irons, radios, clocks, toasters, and refrigerators fueled the Roaring '20s. Demand for electricity continued to grow almost exponentially over the decades as the Northwest contributed to the war effort and the population boomed in the subsequent years. In July 1957, the utility company, now called Puget Power, expanded Plant 2 with a second penstock and a new vertically mounted Francis turbine. The new generator induced 20,500 kilowatts of electricity, an amount nearly equal to the output of Plant 1 and 2 combined. The steady march of technology kept pace with the growing demand for power, continuing to prove Baker's theory that water power could fuel the future. As the politics of the past became a distant memory, Puget Power had begun to fully acknowledge Baker's contribution, which had largely been ignored. In the spring of 1945, they underwrote a radio play explaining Baker's role in the origins of their company.
When I heard it as a child, I thought it was kind of neat that my grandfather was on the radio and that his life was being told.
Charles Baker had a daring dream for those early days, and whenever he expressed his plans, people would call him an idle dreamer. It might even be that this falls right here will someday be used to generate power for places as far away as, Seattle maybe. And Ed, I think I'm the man to see that plan carried out.
When we go back and visit the falls, it's always something that the family has felt a part of, and it's part of our ancestry. I'm, in a sense, a bit overwhelmed in the fact that my grandfather accomplished this.
From its audacious beginnings deep in a cavity beneath Snoqualmie Falls, a power company emerged that proved the viability of water-generated electricity transmitted over hundreds of miles. It set the stage for what would become known today as Puget Sound Energy. Snoqualmie Falls generates a total of 44,400 kilowatts today, enough to light more than 33,000 homes. The prophecy of Moon the Transformer that this lofty cataract would provide sustenance for its people still rings true today and for the known future. A visit to the plant is like traveling back in time more than a century.
When you drop down into the cavity, you realize right away that you have stepped back in time.
In this power plant, not only does the sense of place come from the buildings and the structures, they come from the actual machinery that's being used to generate the power.
You look out onto the top of 4 units that actually existed in their original form for 110 years.
What you're seeing are the same turbines, the same generators. Every single one of those is original.
The lights that were put at the end of the cavity are still there, 1898.
Staring at the hypnotic, cascading falls, one man engineered a means to harness its power, and in so doing, Charles Baker ushered in the age of electricity to this corner of our nation. Defying contemporary scientific notions and the onslaught of political slings and arrows, Baker held confident in a technology still in the earliest days of its infancy. The power plant at Snoqualmie Falls was an engineering marvel of the 19th century that brought power to the masses and forever changed the lives of those living in the Pacific Northwest.
Father and I built the plant with the result that there is no better built plant in the world. It speaks for itself in mockery of our defamers. Snoqualmie will still stand for centuries, and for centuries to come, it will still have the same duty to perform and will perform it faithfully. The same rock chamber will be there and will contain generation after generation of new water wheels and generators with the same never-ceasing din of industry still converting the waste energy of nature to the uses of mankind. Charles Hinckley Baker, 1908.